Hello everyone, welcome to the course on finite element analysis using ANSYS Workbench. This course is designed in such a way that it is helpful for people across the globe who are working on the finite element analysis technology to solve the engineering problems. In this session, we will be discussing about geometry creation and editing in one of the special module in the ANSYS workbench that is called SpaceClaim. We will understand the different regions in the SpaceClaim, basically getting familiar with the GUI and what are the different commands that are available in the SpaceClaim to help the pre-processing part of the finite element analysis. Here is the brief about the window layout of the SpaceClaim. On the right hand side, we can see that the white window at the right is the graphics window or the design window, and the way we use the features in the design modeling softwares like create features, edit features. Likewise, we have here sketching, creating, editing available in the ribbons when we use these tabs like design, sketch, display, assembly, measure, repair, prepare, and so on. And at the top left, we have the quick access tools. And then on the right hand side, we have the help. At the right bottom, there are options which help us for ease of selection of the entities on the geometry. On the left hand side is the tree which keeps a record of the bodies and the reference entities like datum planes, datum axis present in the design window, a kind of a tracker or a tree structure that is placed at the left hand side. Below there are options, which means whatever the command that is being used for building the model or editing the model, we can get the options here. And the properties related to each of the entity selected, we get the properties, get to know about the properties of that selection. The status bar going to show the status of any specific operation that we perform. With this, we will get started with the software application. First, open Workbench. ANSYS Workbench need to be installed in your system. If you have not installed it yet, then please see my previous video in this series on how to download, install ANSYS Workbench. Once the ANSYS Workbench window is open, this is how it looks like. So, about the introduction to the ANSYS Workbench graphic user interface, there is a separate video. I request you to look at that video for better understanding about the GUI of ANSYS Workbench. In this session, we will be discussing more about the SpaceClaim and its available options. First, we'll move to the left hand side in the toolbox for one of the analysis systems, that is static structural. Press hold on that. That is the first mouse button or the left click mouse button. Press hold. The moment we press on that, you can see on the right hand side in the project schematic, there is a green dotted box, which means that is where this project will be now placed. There is a new project created with the name A. We can rename this particular project. Let's say I call it as a C channel fixture. We are going to import some geometry and edit the geometry, that is the C channel fixture. On the material property, we are not changing anything right now since our focus is only on the geometry side. Right click on the geometry and click on import geometry and say here browse. And I'm going to browse geometry, that is channel fixture. Click on open. We can see a right tick mark over here, which means geometry is loaded. Right click on the geometry and say here edit in a SpaceClaim. The SpaceClaim window is now open, which is minimized over here. We click on that. We can see geometry has been imported. This is the design window, the white window what we have where the geometry is imported. And at the top we can see there are different tabs, and below this is called as the ribbon. This is very much similar like the environment that is available in the Microsoft Word or Microsoft Excel, the ribbon and the tabs. On the left hand side is the tree or the structure which keeps the record of the geometries present over here. Whatever the number of components or the parts, solid bodies or surface bodies or the line bodies that are present, those many components are present over here. Not necessarily that there has to be a separate component for separate body. The bodies can be directly in the tree also. Here is the options space wherein we get to select certain options when we are working on the particular command. Last is the properties wherein we can control the properties of each selection or the body. We'll go one by one on the tab. Look at this. This is the first tab is the sketch. The sketch, there are options like create options and edit options, or we also call it as a modify options. Along with that, there are constraints. These options are very similar to the options that are available in any of the design package. Either it is a Autodesk or a CATIA or a ProE or Unigraphics. For creating any geometry, these basic sketches and editing features and the constraints are very much necessary. We'll not go in depth of these things because our focus is understanding about editing the geometry and manipulating the geometry in this session. We'll move on to the next one, that is design. In the design, if at all we wanted to have a new sketch on the any of the plane, then we can directly go into the sketch mode. The option available over here is a cut section. We can just select any of the face nearby or the available faces where we get to have a cut section for understanding the internal construction of the geometry. If we don't want to have it, I will click back on the 3D mode. This is cut section mode and this is the 3D mode. Next option is the pull. The pull is a very interesting command. You can see here we can pull in a direction, or we can rotate that, or we can revolve it, or we can pull it along the direction, or it can be scaled. We select any one of the face and drag that particular face to whatever the depth we wanted. Let's say during the dynamic dragging itself, we enter 100 millimeter. That particular face has been pulled by 100 millimeter. Control Z for undo. Similarly, there is an option called as move. The move option, if this is of 900 millimeter length C channel, we wanted to have it as 1000 millimeter. At that time, we may have to select these particular bodies and pull it to another 100 millimeter. This geometry editing is so simple, and that's why it calls for appreciation for the SpaceClaim. SpaceClaim is a direct modeler. If at all we want to move just a single body, any one of the body, we can select that particular thing and say here move in whichever the direction we wanted to move that one. These movements or the manipulations that we do, there is no track record in the tree over here. If at all we wanted to go back to the previous state, then we just have to do undo. Control Z. Then is the fill. Very nice command, wherein most commonly used for closing the holes or the unwanted pockets in the model. We'll use it over here for the demonstration purpose. Click on the fill over here, select the faces 1, press hold control 2, press hold Control 3. With the Control button pressed, select the faces over here. I want to close these faces and say here done. C channel will be converted to one solid block now. This is how the fill is going to work. The remaining commands like the blend and replace, I'm going to discuss in the next session. Here there are option called as combine. Combine is going to join two bodies. We can see there is one body over here, another body over here, which means in the tree the pillar lies in component 3 because it is highlighting the moment I hover to this body, and then the platform is in component 5. You can see the moment I hover towards platform, it goes to component 5. I select one and press hold Control, select the bottom body, enter. Now these two bodies are combined and they are placed in component number 3. This is how the combine is going to work. Then is the split body. For the ease, I am going to split the bottom body to the vertical pillar, for which I may not need the other bodies, need to be hidden. First channel I am going to hide. Similarly, the right hand side pillar, left pillar we want it, right hand side platform, and right hand side support. We also don't want the left hand side support. This particular block need to be split with these vertical faces. Click on the split body over here. We want to split this body using this face. Similarly, split this body using this face. Similarly, this body with this face and this body with this face. We can see that the body has been split into multiple pieces now. The moment we hover it here at the component 5, we can see one body has been split into multiple pieces. The base body which was present in a particular component, in the same component itself all the split bodies will be created. Similarly, we say right click, show all bodies. Now we'll just leave this body number 5 and go to the other bodies, or we can just switch off this body number 5 and the left hand side pillar, left hand side support, but we want to keep the right hand side pillar, right hand side support and right hand side platform, for which we click on the split body over here. Select this body to be split by using this face. This body with this face, click outside. This body with this face, click outside. This body with this face, click outside, which means the body is now split into multiple pieces. Right click, show all. Here the component in which these subsystems lie, for example the left hand side platform is there, that is component number 5. This component number 5 and the left hand side pillar, I want to make it in a one component itself because it is easy for me to control. Let's say the component 3 has one body, that is a pillar. Press hold on this, move it to component 5. Now in this component 5 we can see that there are all the bodies that are present. We rename this one as LHS pillar. Similarly, now we can switch off this. The first body, that is the component, is the C channel. It may not be necessarily present in the component separately. We can press hold on this component, move it to the main tree so that it moves out of the component. Since this component 1 is now empty, right click on the main here and say delete empty components. Now one component got reduced. Similarly, on the component 2, we can move that particular component to the component 4, where we have multiple pieces of the platform. So press hold on this one and move it to component number 4. Right click on the channel fixture, say here delete empty components. This is going to simplify the tree structure. We can rename this one as RHS pillar. Now we can showcase this also. We have the LHS pillar and the RHS pillar. Then the remaining component, we can move it to the main tree, and the last component we can move to the main tree, and in the last this is the pusher. This also we can move it to the main tree. Right click on this main and say delete empty components. The tree is now very much simplified. This we can rename to C channel. Similarly, we can rename this to RHS support. And this can be renamed to LHS support. And this is the pusher. Rename that to pusher. Now we have learned how to organize the bodies in the tree structure. This makes us easy to identify where is the body and a specific body, in which component are they located. This is how we can make use of the tree organization and these commands to make the pre-processing simpler. Then we move to next command, that is split. Split body is going to split the body as a whole, but split is going to split the surface. For example, we want to establish a connection between this channel and the pillar, for which there has to be a split on this face. So click on this particular face and hover to the nearest edge. It is going to show from this particular start point, it start measuring the distance. There are two ways here, either by percentage or by the actual distance. We press on tab over there and 110. This particular face is being split into two pieces now. This face also can be split. Click on this and hover the point to this end point. The face will be split. Similarly, split this face. Move to the bottom, split the face over here. Make sure that there is no numbers visible, which means there is a proper intersection that is happening. Click on that face and hover to the vertex. Similarly, on this face, we click on this particular surface, hover to the edge, press tab, enter 100, so that at 100 distance from the right end, the surface will be split. Similarly, it should not be 100, it should be 110. Tab 110, enter. We split this face, intersect over here. We split this face, move the pointer to this edge. Similarly, click on this face split, move the pointer over here, split this face and move the pointer over here. Now there is an appropriate split. Make sure that the splitting has happened exactly at the intersection. This has given us a bit understanding about playing with the split and split body. Then is the project. This particular pusher need to be projected on this face to have a split on the surfaces. So we don't have to go for the split. We can directly go for the project. How the project work? The moment we click on the project over here, bottom we can see a message, select one or more faces or lines to project. So we want to project this line and we want to project, press hold control, this line. If we observe, it is getting projected on the top face and the fillet face and the back face. Our goal is to project on the target face. So select the target face and select only this face so that the projection happens only at this particular face. This is the direction. We are going to make this only vertical direction. Or we can just project that one by one say here project. We are going to select this particular face and the target face is going to be this face. Click on done. To visualize this split that has happened, we have to hide the pusher. We can get to see that split has happened. Now pusher on, go to the project again, project this particular edge and the target face is this top face. Click on done. Now hide the pusher to see that projection is complete. Here we have the options for creating the datum planes and datum axis. We'll understand how that is going to work. Click on the datum plane over here. Select any of the face. That particular face will have a datum plane aligned to the face. We can click on the move and select that plane to move to the distance that is desired. The plane can be created in multiple ways: tangent to surface and parallel to face, passing through the edge or angle to one particular face, and so on. Based on the application or the requirement, that can be utilized. Similarly, the axis can be used by selecting the edge or by selecting any of the two vertices. We can create the axis. Escape command can be used to come out of all the commands. We click on one vertex, press hold control another vertex, click on the datum axis. So datum axis can be created by using 2 points as well. The commands like linear pattern, circular pattern and the group pattern also can be used when we are dealing with creating the multiple bodies. Then on the display, we can make certain bodies transparent by selecting a particular body, let's say C channel, and change its condition from opaque to transparent. Change it back to opaque as required. The graphics can be changed from wireframe to the shaded geometries like this. We click on the C channel back and say here opaque. Transparency has been removed. We may not need the datum axis, click on that and delete it. We may not need the plane, delete the plane as well. Then on the assembly, if we are interested in adding the files to this existing assembly, we can say here file, and the file can be imported to this same file. We can also use the constraints of the assembly like tangent, align, mate, orient, and so on. Next one is the measure. This will help us to measure the distance between two bodies. First vertex, press hold control the second vertex. The approximate distance or the exact distance between this is 900 millimeter. If at all we don't want to use this measure command, let's say we are in any of the tab, just by clicking the edge, it is going to show what is the distance or the length of that particular entity at the right, at the center bottom here. Length equal to 100 millimeter. We can click on the arc over here. It says radius equal to 50 millimeter. For the regular geometries, SpaceClaim is going to identify its shape, the basic shape. Either it is a circular or linear. Based on that, it shows the radius or the length of it. Then we come to the repair. Repair is one of the predominantly used command whenever dealing with the geometries with the imperfections. Most of the times for the finite element analysis department, when they get a geometries from the design team, there will be some surface imperfections either because of the inadequate experience of the design engineer or maybe some data loss during the file transfer or format conversion. In that time, there may be some gaps between the surfaces or some of the edges of two faces may not be intersecting with each other, or the face of the geometry itself might be missing. Or even though surface is there, edge is there, the edges might be split. Or there may be some duplicates of the edges. Or maybe there are duplicates of the surfaces itself. To deal with all those imperfections, the repair tab will be used. wherein the stitch, if there are gaps present, it is going to automatically identify where the gap is. That will help us to stitch that particular gap. Right now, when we say here stitch, there are no areas found. Similarly, gaps on the right center, we can see no areas found. Missing faces, again no areas found. Split edges, no areas found. Extra edges and duplicates and so on. So here we can see some extra edges and duplicates. Yes, because we have made the split in the bodies, especially on the platform, this is bound to happen. How to deal with this, I will let you know in a minute. Then coming to the prepare, whenever we are dealing with geometries, wherein we don't want to consider the solid geometries as is, but we want to extract the neutral surface of the geometry, let's say like a sheet metal part, the way we have the C channel over here. At that time, we use the command mid surface. Mid surface, we select just one face and another face at the bottom. It is going to recognize these two faces, and approximately at the left hand side we can see thickness is 4.09 millimeter. When I say here done, the mid surface of that particular C channel has been extracted. The C channel part is now suppressed and mid surface has been extracted out of that. I'll say here undo. This is how the mid surface can be used whenever we want to analyze it with the shell elements. We discuss more about shell element in our next sessions. Then we have to extract the mid surfaces of the sheet metal bodies or the constant wall thickness bodies. When you're dealing with CFD models for creating the volumes or extracting the volumes, there is an option here to extract the volumes as well. To build connections, weld and spot welds also can be used. Moving on to the next option, that is workbench. What we have seen is the pillar assembly is made up of pillar and the platform. So in this case, we'll hide all the bodies and keep only, let's say, the LHS pillar. LHS pillar has a vertical pillar and the platform. Even though these bodies are independent of each other, the relation between these bodies can be built. Initial observations that we do here is there is no any special mark on this component. It is just a simple component identification. When we click on the share over here under the workbench, the common edges between the bodies will be shared. We say here done. The moment we say done, we can see a magenta and yellow lines are being created here at the edges. And the color of the component also has been now upgraded, which means the bodies that are present in this particular component are now shared. What exactly does this mean? When there is a share that is happening, that is a share topology that happens, at that time there is no need to define additional contact between them or combining these bodies for gluing purpose. There will be a node sharing, node to node connectivity that is going to be built when this model is taken to the ANSYS workbench. I repeat, when we make this share topology between the bodies, it is going to showcase the magenta and the yellow lines for which the connections or the node sharing will be built between the bodies. No additional definition of the contact is required. Similarly, we switch off this and switch on the right hand side a pillar assembly with a platform and click on the share over here. Again, it identified that there are 9 faces and the 24 edges that can be shared, and say here done. For both these bodies, now we can see that the share topology icon has come. Right click on this, click on view and say here isometric view. This is the isometric representation of the view. Right click view, click on the front view. We don't expect this to be the front view because we believe this looks like a left view to us. Right click on the view and say here top. How do we orient the geometry in such conditions? There is a command called as move. We'll go to the design here and say here move. What do we want to move? We want to move this entire thing. Move does not necessarily mean only translation. We can rotate as well. All the bodies we are going to press hold, select and rotate them. I think we should rotate them by 270. We can directly enter the value during the dynamic rotation itself, 270, enter. The body is now entirely rotated. Right click, click on the view, say here front. Now this is the front view. Right click, view, say here left. All these views will be get adjusted because the entire geometry itself has been oriented now. View, click on the top. I just want to go back to our presentation to see anything is missed. So we talked about the tabs, the design window, selection tools. Selection tools I will be taking you in a minute. SpaceClaim properties using the mouse buttons, tree options and so on. On the right hand side, here there are selection tools which we can use, that box selection or with a selection filter like smart, transparent objects and so on. We are going to use this very rarely because most of the selection processes can be taken care without the use of this special tool also. To discuss about how do we handle this geometry, right click, view, front. This is about orientation of the view, and scroll will be used to zoom in, zoom out. Press hold middle mouse button and move the mouse to rotate the body. Press hold control and press hold middle mouse button and move the mouse to move the bodies. This is the way we can deal with the mouse to move the bodies. Mouse and the keyboard shortcuts to move the bodies. The body can be saved and click on File, Save here, or we can say Save As. When we say Save As, from the SpaceClaim, the body will be saved in SpaceClaim doc file, that is .scdoc file. This format you have to make a note. Cancel that. I hope this session has given you a very good understanding about the SpaceClaim. If you have doubts about this particular session, you can be in touch with me on my phone and the WhatsApp here, 9481635839. This is the India number. Or you can write an email to me on caewhelp@gmail.com, or you can also visit my channel, that is GRS CAD CAE in the YouTube. I will see you in the next session. Till then, take care and bye bye.